Hello everyone, I am Nand Kishore Yadav from ABES Engineering College. Today, I am here to discuss introduction to data structure and its operations. Firstly, let me introduce what is a stack. So, stack is a linear data structure in which insertion and deletion can be done only at one end. That end is known as top. In our daily life, we can see similar operations where the stack type operations have been performed. So let's take an example of a disk box. In the disk box, we can see that there is one end free and other end is fixed. Suppose we want to insert some CDs in this box. So firstly, suppose we have inserted disk 1, then we have inserted disk 2, then we have inserted disk 3, we have inserted disk 4 here. So now, so this is top disk is this one. So the disk which we have inserted at last is at top position. Now, if we want to remove disk from this arrangement, then firstly, what we will remove, we will remove the disk 4 from the arrangement. So the disk which we have inserted at last, we have to remove first. So here, in this arrangement, basically, last in first out arrangement is followed. Similarly, in data structures, stack is also follow the same arrangement where it can be say that a stack is a collection of homogeneous elements which is based on last in first out arrangement. In data structures, stack is represented in memory, which can be uh, seen in next slide. So here there are two ways to represent a linked list in memory. One is using array, and other one is using linked list. Array representation is known as sequential memory representation, where we have to take an array to store a stack data structure, and this array is behave like last in first out arrangement. Similarly, in the linked list representation, we have to take a linked list to perform similar type of operations. There are various operations which can be performed onto the stack, such as initialization operation, emptiness check, push operation, pop operation, reverse operation, finding stack top element from the stack. That is also known as peak operation. In initialization operation, we have to initialize the variables used in a stack, such as we have to initialize top variable here. And in emptiness check, we have to check any element is inserted onto the stack or not. If no element is inserted, then we have to set the value of top is -1 or null in the case of link. Here, the push operation is an insertion operation where we have to insert a single element onto stack. In pop operation, we have to perform deletion operation where we have to delete a single element from the stack. In traversing operation, we have to print or visit each element at least once. So here we will print from a starting element to last element, check whether all the element we have inserted in the stack zone or not. If we want to find the top element from the stack, then that is called the peak operation. After seeing these operations, so let me introduce one of the important algorithm, that is push operation, where we will see how an element can be inserted onto a stack. For that, we are using array representation here. Suppose we are having an array like this. This is an array. So we are assuming that the name of this array is stack here, and size is 5. So here we can see this is 0th index in that array. This is 1 index. This is 2 index. This is 3, and this is 4. We can insert maximum 5 elements in this array. Suppose we want to insert some elements like 20, 10, 30, 11, and 19, and 20 in this array. So in starting, if array is empty, at this position we can say the value of top is -1 in the case of array representation. If we want to insert 20 here, then firstly what we have to do, we have to set the top value at 0. So we have to top at this location. So now we have to set top at 0 and put 20 at stack. So after setting value of top at 0, we have to put stack top is equal to 20. So we have to put 20 here. Similarly, if we want to insert 10, then what we do? We have to increment the top. It means that we have to, what we have to do, top, we have to perform top is equal to top plus 1. So here, what we do? We have to change the value from 0 plus 1 to this will be equal to 1. Now stack top again is 10. Similarly, we can insert 30. When value of top is 2 now, then increment the value of top, then we can insert 19. And if increment value at 4, value of top at 4, we can insert 20. Now we can see the stack is full. So here we can see that if the value of top is size -1, so size is 5 here, so value of top is size -1, then we can't insert 21 here. So this condition is called overflow. So how do we write the push algorithm here? Using these steps, we can write the push algorithm. So here, push. Now we have taken a stack data structure here. Okay. Then we have to insert a data here. Now in the first step, what we do? We write the overflow condition. If top is equal to size -1, then print overflow. Overflow and exit from it. In the second step, we see if the stack is empty, then insert first element. So if top is equal to -1, then print, then set top is equal to, or it can be if there is already some value of top, and in next case we have to see what will be the next value of top. So if else what we do, we simply increment the value of top. Top is equal to top plus. At fourth step, what we do, we have to insert the data at this top position. So we have to take a stack data structure here. Stack at top is equal to data. Okay. At fifth location, we write the exit. So using these 5 steps, we can perform the push operations onto the stack. So here we have seen the overflow case also. We have also checked the emptiness of the stack, and if the stack is not empty, then we have inserted the data on the top of the stack. Now next algorithm is pop algorithm. So similarly, if you want to delete a data from the stack, then we will call the pop operation. What we write here, we will write the algorithm for pop op. pop, and here we are having a stack of size 5. Then in the first step, we check is there an element onto the stack or not. It means that we have to find the emptiness condition here. So if top is equal to -1, then print stack is underflow. So here we have checked the underflow condition. If the stack is empty, then this condition is called underflow and exit from it. And similarly, we can exit from it. In the second case, if the stack is not underflow, there is some value of top in that particular. So next, we have to find the data which we want to delete. So in that case, what we write, data is now what? Data is the value which is at the top of the stack. So stack of top is data here. Now we have selected the data we want to delete. Then we can decrement the value of top. Now we can perform top is equal to top minus. So here, firstly, we have selected the data what we want to pop from the stack. Then we decrement the value of top in next case. And in fourth step, we can perform the action. So suppose we are having this algorithm, which is called the pop operation onto the stack. Then we will see the next algorithm that is called the traversing operation onto the stack. In this algorithm, suppose this is stack is given to us, where uh, the starting index is 1, then next index is 2, then 3, then 4. So this is the stack data structure which is stack of 5 elements, okay, given to us. Now values are like 20 and 30 here, which is already given. Now that this is the top index. Now, value of top is 3 now, 2 now. Now suppose we want to print all the elements, then we have to apply the traversing operation. Firstly, what we do, so for traverse operation, what we do, we have to take a stack data structure. Now, next step, what we do, we initialize the value of top from 0 to a top position. Firstly, we have take a counter I is equal to 0 because stack is started 0. Now, in the second step, what we write, repeat steps, while I is less than or equal to. And third step, print stack top in fourth step, we increment the value of top. We have to write I is equal to I plus. And fifth step, we have to perform again. So in traversing operation, what we do, we just started with the starting position, the starting index that is 0. So firstly, we will print 20. Then repeat step 3 and 4 while top is less than. Now top is 2 here, it's not 0. So again, what we do, print the value of top 20 and increment the value of I, that is I is equal to, I is now 0 here. Then the value of I is I plus 1. Now from here value is I is. Now again, we check the value is, value of top is less than or equal to top. Condition is okay now. Then again print the stack top position, that will print 10. Then again increment the value of I, that will be from now 2. Then again check if I is less than is equal to top. Yes, condition is okay now. Now again print next value, that is stack top is 30. Then after incrementing value 2 to 3, the term condition is matched, then the loop will be terminated. And after termination, we can see that we have printed this element. So in this one, we have seen three algorithms. One is push algorithm for the stack, and second one is pop algorithm for the stack, and third one is traversing operation for the stack. Thank you.